Right, so this happens more or less every single time I make a video about a wind turbine. I get loads of posts going, yeah, okay, so how much did it generate? Well, yeah, oh bless you. It can't generate any more than the power of the wind that's blowing it. It's impossible. Let's say, for example, I spent all day chucking garden peas at you. The only thing that's going to happen is you're going to get irritated because you're covered in peas. If I start chucking basketballs at you at the same force, it's going to hurt. And it's going to hurt because of one reason. Basketballs are bigger. There's more energy in a volume of something if that volume is bigger. Now, the density of the wind doesn't really change. So if I was chucking concrete at you or steel ball bearings, that would hurt, because you've got two things here. You've got the speed at which it's moving and the mass of the thing that's being chucked at you. And that's going to depend on how much it hurts. Now, it's just the same with the wind turbine. A wind turbine is going to produce energy because there's wind hitting it. It will be less than the energy that is in the wind. It must be. So if I have a turbine like this and I turn a hairdryer on that section there, that's the amount of air that's hitting it. Not all of that, just that bit. So that bit we got a result from. Obviously what we need to do is stick that so the whole thing is in the air, and then we get a better reading out of it without a doubt, because the whole of the air is hitting it. It's a bigger volume. Now, of course, this is 9 centimetres in diameter. If the diameter was bigger, it could catch a greater volume of the air, and so it would output more. It's only going to output directly related to the speed that the wind is travelling and the area of wind that is going to hit this. Those are the two factors that determine how well a wind turbine is going to perform. Now, a wind turbine, the whole point of this section is to grab that energy out of the wind, whatever it is, and turn it into a rotation. It's the amount of rotation, the turning force that you can get on a wind turbine that determines how well a wind turbine is actually performing. How much it generates isn't actually a measure of that. How strong that turning force is, it's a measure of how well the wind turbine is performing. Now, we invariably stick that onto a motor of some description or a generator of some description, and that turning force is turned into a rotation which will generate the electricity. Now, these things have a very variable efficiency, somewhere between 65 and 80%, depending on what it is that uses a generator. And that's the way it is with generators. They have that kind of efficiency. If you want to spend money on this to improve the efficiency, well, your generation is going to go up, but you won't get any more power out of it than the power that is hitting this. So the power that hits this, how that's translated into turning force here, is the actual measure of how a rotor part of a turbine will work. Now, in order to do that, what we need to do is measure the torque. If we measure the torque on it, we'd use something like a Prony brake, and that would tell us what the torque on this actually is, and that would tell us how efficient this was at capturing the energy in the wind and turning that energy into turning force. Generation is not a measure of that. Generation, how much it generates, is a measure of how much this is actually capturing as turning force, and then how efficient that is at changing that turning force into electrical generation. So if I got a standard wind turbine that has been measured endlessly and stuck it on here, then I'd get a figure out that would compare those two. So if I want to measure what the efficiency of this is in relation to another type of wind turbine, I can just change the rotor and see what the reading is, and that will tell us, because you're using the same yardstick. If you're actually trying to get a measure of efficiency of a rotor from generation, because you're measuring two things, then that measure is not going to be anywhere near accurate or give you sufficient information. All you can really tell is that it's working to a degree that's acceptable. That's all you can tell from such things. Without spending a huge amount of time necessary to understand what torque has been generated by this, there's very little you can say about any particular generator. You look at the things that people are doing and they say, oh, look at that, isn't that awesome generation? Just check that what they're saying that they generate is what's available in the wind, because the wind power that's available is going to be the top limit of what you can get out of it. If they're beyond that top limit, they're basically lying to you. Now, don't forget the Betz limit as well. You're not going to get all of the energy out of the wind, because if you did that, then the wind on the other side is like a brick wall, and you just create a pressure difference and it'll stop turning. The wind has to flow. Because it has to flow, you can't take all of the movement out of it. So the Betz limit does actually apply. So, in fact, if you're getting a figure roughly greater than about 30%, I mean, that's a guide, it's a sort of a rule of thumb. If it's about 30% of what's available in the wind, then the chances are you're not being tracked totally to the truth. Let's be nice about this. So when you're looking at wind turbines and trying to assess how well they're doing, what you really need to be asking is, what's the torque on that shaft there? You can get the answer to what the torque on that shaft is, then you've got a good description of how that wind turbine's doing. Now, I'm not about to measure the torque, mostly because I can't. And so all I actually do is a few demonstrations of what it can actually do, but then what I'm concerned with is the price of things. Remember, this was free. This cost me £2. So I spent £2 on making a mini generator that actually does okay, and I'm quite pleased about that. Anyway, I thought I'd cover that because, like I say, it's almost invariable. People say, so what's it generating? And it's almost invariably insignificant. We don't measure the torque. What the real question should be is, what's that torque on that turning shaft? And if somebody asked that question, I'd be super impressed. But nobody asks it. The reason I tend to use an LED, incidentally, is just so you can see it. I also do fixed resistors. This here is a little filament lamp. It's a fixed resistor. So I'm getting a resistive load on that, which can give me some idea, a better idea of what the output is. Anyway, I thought I'd cover that, because it does seem to be an endless question people ask, and I've never really understood the question. It's like I say, when you want to know how well that bit's doing, what you're interested in is, what's the torque right there? If you want to know how both those bits are doing, then sure, generation. If you want to know how that bit does, then you're looking at applied torque and how much it generates for the applied torque. Anyway, I hope the video was of interest. Thank you very much for watching, and please do remember to like and subscribe.